As everyone's joining, you'll notice that we're enjoying a video by one of our presenters, Mark Hirsch. So we're doing something a little different today and easing you in with some setting the stage and the tone for our presentation. So enjoy that while we wait for people to hop on. So we're going to get started here, and you will see a little bit more of that video later. So thank you everyone for being here with us this evening, afternoon. I don't know. I can't say evening anymore now that it's like firmly spring, almost summer. Very sunny outside to be evening. But thank you everybody for joining. It's spring. We're in our very last lecture of our 2021 lecture series. And for anybody who doesn't know me, I'm Kate Swanson. I'm the Interpretation and Public Engagement Educator at the Rockwell Museum. And I'm thrilled to be presenting the final lecture in our 2021 Environments Examined lecture series. I'm amazed that we've managed to pull off our all virtual lecture series this year. And it's really exciting, you know, having started working on these virtually last April, to be in a place where we can start to envision and imagine being together in person again when we do this next year for 2022. I'm really grateful to all the speakers that we've hosted and my Rockwell colleagues, and especially our events coordinator, Janelle Steiner, for making this such an incredible year. We've examined environments in landscape painting, architecture, environments in the future, environments through craft. And today we're going to be taking a look at how migratory animals impact and are impacted by the environment. It's going to be much more complex than that, but that's what my art historian vocab can handle to explain it to you for now. And we're going to look at how that data that we use to track that impact can help us see things in a new way. Our presenters are actually spread out across the country today, which is exciting. One really exciting aspect of being virtual. But here at the Rockwell Museum, an important part that we always want to recognize of our environment is that we're located on the ancestral land of the Seneca, one of the 6 nations of the Haudenosaunee or Iroquois Confederacy. As we examine the natural world, it's important to remember and recognize these man-made boundaries and jurisdictions and borders that we've kind of imposed on our environments and how those affect us. And not only us, but the animals that we share our planet with as well, which is something we'll get into a little bit today. So moving on to the more important things. Our talk today, you're getting a lot of bang for your buck. We have not 1, not 2, not 3, but 4 presenters, which is something we haven't done yet in this series. We have a panel this evening. We have Jared Stabeck, Lynn Harrison, Mark Hirsch, and Martin Collins. And you will learn all about all of them, but in order to get to the good stuff, I'm just going to introduce one to kick things off. Martin Collins will act as our moderator for the panelists this evening. Martin Collins, PhD, is curator and historian in the National Air and Space Museum's Department of Space History, with a focus on the technology and culture of the space age. His current exhibition projects include One World Connected, a look at the role of aviation and space flight in recent globalization and climate crisis. He served for 8 years as editor-in-chief of the journal History and Technology, an international journal, and is presently the managing editor of the book series Artifacts, Studies in the History of Science and Technology, published by the Smithsonian Institute Scholarly Press. And his most recent book publication is A Telephone for the World, Motorola, Iridium, and the Making of the Global Age, published by Johns Hopkins University Press. So with that, Martin, I will turn things over to you and let the panelists take it away. Thank you.
Anyway, to begin things here, as Kate suggested, I will attempt to serve as moderator. What I'd like to do just to begin is to just sketch out a little bit of the context of the work of our presenters, specifically as it relates to the Smithsonian Institution. I think, many of you have, come down to the mall and visited the many museums there. And through that experience, you get especially a strong impression of the Smithsonian's work in history, culture, and the arts. But beyond all that, the science enterprise at the Smithsonian fundamentally is the largest share of what we do in terms of resources and personnel. It far exceeds what we devote to these other categories and experiences for our visitors. So part of what we're sharing tonight is a little bit of a window from that much larger set of scientific activities within the Smithsonian. And I think also, it's useful to point out in relationship to our talk tonight that the Smithsonian, particularly in its scientific dimensions, is really a global institution. If you look at a map of the world and locate all those different points where Smithsonian scientists and their collaborators are working on different kinds of projects, whether it's conservation or other sort of aspects of science. Literally, we are represented on every continent and in multiple places on every continent. So we have this kind of perspective when it comes to science, not as a kind of narrow American-oriented enterprise, but one that is fundamentally international in scope. And the way that research problems are pursued are within that kind of broader context, and which gives, I think, especially topics like conservation science and issues like climate change, gives the Smithsonian a kind of special, I think, position in helping along those discussions. The other thing I think more specific to this evening is how over time, say in the last decade or so, the Smithsonian itself has become much more conscious about how the multiple projects that it does under the label of conservation science need to be in conversation, not only across the Smithsonian in the different units and institutes, but again, with collaborating organizations around the world, whether it's universities or governments, or even aspects of the United Nations. So it's a very broad palette, and within the Smithsonian context, that sort of notion of a conservation commons is a very kind of useful device to kind of bring all of these different aspects of research together and to show the power of how they can be combined and provide sort of deeper insight into the natural world. And I think, certainly as we've experienced over the last year with the pandemic, the global sort of character of many of these problems is very in the forefront of our minds. And this kind of research, though not directly connected to that immediate issue that we've all dealt with over the last year, is again sort of within the same kind of frame of understanding and research and collaboration to get to solutions. And the Smithsonian, takes on this idea of solutions as a particular capability which it can help encourage. With all these different research projects in conservation science, many of them are aimed at not only understanding specific natural phenomena, like we'll hear from my colleagues tonight, but also as a way to begin to kind of work with others, and whether it's, again, it's the scale of local communities or somewhat larger than that, to find sort of solutions to issues of changes in the environment that are around them. How can we do what we do on a day-to-day basis to provide for ourselves, to feed our families, to live a fulfilling life? How do all of these, kind of connect to our own ecosystems, and what they can do for us and what we can do for them? So that's sort of the larger scope of things. And I think it's, kind of worth pointing out, in the lecture title here, Kate used the word Anthropocene. I mean, that's kind of a clumsy word. But on the other hand, it sort of highlights the kind of tensions and challenges associated with the kind of work we're going to talk about tonight. Because the climate change and other changes that we're seeing in our environment on a planetary scale have some sort of natural dimension to them, but largely are driven by human activity. So we are, in essence, as we think about saving the planet, also having a conversation about the way we live and how that impacts our ability to do a better job as stewards of the planet. So with that very kind of broad strokes, it'll be useful to kind of get down and understand, what our colleagues are doing. I'm going to give very short intros to our panelists and let their work speak for itself, and kind of reveal how they themselves as researchers engage with that research and what it means to them. So the structure of the program will be each of the panelists will present a short rendering of their own work and what is going on with it and what it means to them. After that, we'll segue into a conversation with the panelists and take up some of the questions that inform their research activities and their own sense of their relationship to that research. And then last, of course, we will open things up for questions from the audience and have a conversation with you as we kind of move toward the end of the program. So to begin, let me introduce Jared Staubach, and as I'm adjusting multiple computer screens here. Jared is an ecologist at the Smithsonian Conservation Biology Institute's Conservation Ecology Center, another one of these far-flung aspects of Smithsonian life that sits out near Front Royal, Virginia, an hour and a half or 2 hours away from Washington, D.C. And he is coordinator of the Smithsonian's Movement of Life initiative, which you will hear much more about in their presentations. And his research focuses on factors that affect the abundance, distribution, and movement patterns of large terrestrial mammals. And if you watch PBS or his History Channel in National Geographic, you will see a lot of material on this, but he comes to this with a very deep and interesting scientific approach. And one of his sort of signature methodological approaches is to use technology in its different dimensions, whether it's GPS or airplanes or drones or satellite imagery, to help him do what he does. Lynn Harrison is a research ecologist with the Smithsonian Migratory Bird Center and program manager of the Migratory Connectivity Project. And I think you'll get a better sense of what that means when she does her presentation. And it is part of the Smithsonian's National Zoological Park. And she studied not only birds, but also sea life. And so it includes shorebird, seals, sea turtles, and applies this research to, as I was sort of suggesting earlier, to practical applications in conservation and management of natural resources. And lastly, our representative here with respect to art, Mark Hirsch is a PhD candidate at the University of California, Santa Barbara, within the Department of Media Arts and the Technology program. And his work investigates, and you'll see the intersections with Autumn, Lynn's, and Jared's work, machine learning and artificial intelligence as tools for creative practice, and data-driven approaches to making art that connect form and information, which was part of what that initial animation that you saw was all about. So to begin, to kick us off and kind of sharing their work, please go ahead, Jared.
Yeah, thanks, Martin. Appreciate the introduction, and also thank you all for joining us this evening. Like Martin mentioned, I'm an ecologist, and so my interests really lie with the understanding of how species interact with their environment, with a specific focus on the factors that contribute to the abundance and the distribution of large terrestrial mammals globally. And that means that some of the species that I tend to work with are elephants and giraffe, and like the picture shows here, wildebeest. Martin also mentioned that a lot of my work incorporates emerging technologies like GPS tracking collars. Like this is the type of unit that we would place on a large terrestrial mammal. But I'm also engaged with using machine learning, so overlapping with Mark, and then also incorporating information from drones and high resolution satellite imagery, but always in the respect of trying to understand how animals are responding to environmental change. Kate, you can go to the next slide, please. What I thought I would do is give you just a really brief background on this initiative that the Smithsonian has referred to as the movement of life. And when it comes down to it, this initiative has a simple idea, and it's really just that we're better equipped to deal with the challenges of the 21st century, this Anthropocene, by working together with one another, sharing experiences and sharing expertise. The movement of life really has 4 fundamental goals. The first of which fits in very well with the fact that the Smithsonian is a scientific institution. So at the core of our initiative is research and discovery. And in this case, research and discovery of mobile species, always with the ultimate goal of improving conservation outcomes. Secondly, the mission of the Smithsonian is the diffusion of knowledge. And so one of the things that we want to do is provide better access to data and also better access to new analytical tools so that we can grow this community of conservation-minded scientists. Thirdly, we aim to collaborate with individuals and institutions, really to push the envelope on, in many cases, novel tracking technologies. So one of the issues we have is that many of the devices are far too large for the vast majority of species if we want to really understand where these animals go throughout their life cycle. And this really means engaging and pushing that envelope on the types of devices that we're able to fit on animals, really miniaturizing these devices or finding ways that the batteries actually last for longer time periods. And lastly, and this also fits in with the mission of the Smithsonian as an educational institution, is how do we better engage the public on this incredible phenomenon known as migration. People, I think, generally want to conserve the things that they love. And at the same time, we generally love the things that we better understand. And so I think movement of life really is trying to close that loop, starting with groundbreaking fundamental research about the animal's ecology, but then providing that scientific information in really engaging stories about where these animals that we tracked actually went throughout their lifetime, to get people more interested in global biodiversity, but also the biodiversity that exists in their own backyards. One of the things that we've learned over many decades of research, like research on these caribou, is that movement is a fundamental process. All living things have to move, and they move with changing environmental conditions. Animals move to find resources. Animals move to find mates. Animals also move to avoid predators. As animals move, they eat, they defecate, and in turn, they tend to circulate nutrients across their local environment and then more broadly across large ecosystems. So this is a fundamental ecosystem process that cannot be replaced. Animal movement data, when we're tracking individuals, like we're tracking these pronghorn antelope, has also very tangible benefits. In this case, what we're able to see just by monitoring individuals and where the key connections are across the landscapes. By providing this information to land managers, we actually can effectively create corridors and make connections across what is becoming increasingly fragmented landscapes. Animal movement at the same time can also be extremely interesting to look at, like the collective movements of these starlings. This is also often referred to as a murmuration, and also can simply be thought of as an aerial ballet. Sometimes the pattern as animals move across the landscape also can provide interesting patterns, like when one species responds to the presence of another. Sometimes these patterns can be artistic, but also they can be quite abstract. And the last thing I wanted to leave you with, and it really fits in with what Mark and I talked about for a long time, is this movement trajectory of an individual wildebeest. Now, if you looked at this really closely, at least at a first glance, you might think that this was a mid-century Jackson Pollock, especially if I added some color to the movement trajectory. In science terms, we would refer to this as the occurrence distribution of the animal, with areas that are darker being areas that the animal spent more time at. So they have a higher density of use. And I think if you're a scientist or even just an interested onlooker, it starts to generate questions in your mind about why and how the animal moved this way. What are the reasons that the animal spent more time than others in the areas that are darker? Was it resources? Was it because these areas were further away from human disturbance? These are really the type of things that we're trying to put together when we try to answer why an animal is on the landscape, but with the ultimate goal of trying to protect these animals into the future. So those are just a few words to get things started, and I'll hand things back to Martin to introduce Autumn Lynn.
Scientists who study birds like me are no strangers to artistic representations. John James Audubon captured the beauty of our native birds in North America in his stunning and seminal work, The Birds of North America. This species shown from Audubon's work on the left is a brown pelican, and from my field research on the right, the same species. One of the migratory birds I study at the Smithsonian Migratory Bird Center, and a story I'll share tonight. Next slide. And bird migration as a process is a beautiful piece of art. The animation that you will see next shows the migration paths of common nighthawks from the boreal forest all the way to South America. I love studying migration. This is a real passion of mine, and so I just feel so fortunate to be able to do this for my job. Each line that you see here represents an individual bird that we have tracked with a tiny GPS tag using the same technology as the GPS on your phone. And we are able to follow for the first time their full migrations across the Western Hemisphere, from breeding to their overwintering sites in the Amazon. Different populations mix and mingle throughout the South American forests. And even during this wintering period, they're moving around across South America, something we would call intratropical migration. And now you'll start to see some of the first individuals hinting at making their way back north. They will all cross the Gulf of Mexico, and typically for a bird like this that is not a seabird, that is a risky part of their journey. And so these amazing technologies allow us to see how fast they make these crossings, where they might be at risk. And then finally, we'll see them distribute across North America back to their breeding sites throughout the Northern Hemisphere. In the 1980s, transmitters that communicated with satellites and could be carried by birds first arrived as a tool for scientists. The first known deployments of satellite tags were on really large birds, eagles, swans, and southern giant petrels in 1984 and 1985. Next slide. Today, some of the electronic tags that I use to track the migrations of birds are very tiny, the size of a small medicine pill. I use these tiny tags to track the migrations of this bird. Please click. This is an Arctic tern. It is the animal in the world that makes the longest migration that we know of from the Arctic region all the way to the Antarctic. And for these tiny tags, here is the little tag that you can see on the leg of the bird there. We actually have to recapture the bird after a year to recover these tags and download the data. This is really the honor for me as a migration biologist to hold in my hands this little athlete, this amazing athlete that would win the Olympics, the Bird Olympics, making this amazing journey. Please click. And just to show you again, oh, that's okay, we can skip. That was a quick window to Audubon's painting of the Arctic tern. I manage a project at the Smithsonian called the Migratory Connectivity Project. Over the last 5 years, we have tracked the movements of 23 different species of birds. And you can see in this figure that these animal movements span the entire planet using these tiny technologies. For many of these species, this was the first time that we had ever discovered their migration path. And for others, these data are critical to information planning. What you see on this map, every single dot represents a daily location of a bird that we've tracked, and every color is a different species. Next slide. And one species that I've had the fortune to study close to home is the brown pelican. You'll hear about this bird a lot tonight. She is Aunt Hazel. And usually as scientists, we don't tend to anthropomorphize the animals that we study. They are part of nature. They aren't part necessarily of our human world, but she is an ambassador for a changing landscape and seascape. She's an ambassador for the culture of the place where I'm from, the Chesapeake Bay. And brown pelicans are a conservation success story. Next slide. This house on an island in the middle of the Chesapeake Bay, part of Dorchester County, Maryland, was once in the family of my best friend. Her great aunt Hazel was one of the last babies born on Holland Island. There was once a thriving community on the island with roads, a church, and a school. Many people made their living working on the water, crabbing and oyster tonging. And this was the last house standing on the island before the community relocated off the island and the island began to wear away through natural processes of erosion and subsidence. Long before actually we were really worried about climate change. But now islands in the Chesapeake face also rising sea levels. Next slide. During my childhood, the island looked like this. That same house being the only single house still standing on the island. Next slide. And then the pelicans moved in. In the hurricane season of 2010, This house crumbled into the Chesapeake Bay, and most of the island went with it, but not all of it. Next slide. Pelicans only came to the Chesapeake in 1987. They took advantage of these islands that were in a state of transition. And after the pesticide DDT was banned, about 15 years after, they arrived in the Chesapeake to nest for the first time, probably moving north from the Carolinas. So this place really has special significance to me, and I wanted to study how the population of pelicans, the most northern population nesting on the East Coast, was using the Chesapeake and honor the families and the island culture of the Chesapeake by sharing their story. So each pelican we tracked was named after one of the family names, still on the gravestones that still stand on the island. But the only female that I tracked, Aunt Hazel, is in honor of that last baby born on Holland Island. Next slide. And these are the scientific representations of pelican movements in the Chesapeake Bay, showing very literally where they move in the Bay and beyond, and their migrations to the Carolinas and even as far as Cuba. And next, we'll get to see Mark's interpretation of Jared's wildebeest tracking data and Aunt Hazel's movements in the Chesapeake Bay. Thank you.
Thank you, Autumn Lynn. Yeah, I think both your and Jared's presentations nicely set up Mark's specialty interest in visualization as a creative practice and to pose questions for us to think about. Go ahead, Mark.
Excellent. Thank you, Martin. Yeah, just like was just mentioned, this is a great setup for one of the artistic practices that I'm most excited about and I spend a lot of my time doing. And so I sometimes like to think of myself as a data artist, and I use data visualization as a kind of jumping off point, both for communicating ideas and thinking about that, but also as a form of artistic inquiry. And if we go to the next slide, we can see three areas that I tend to focus a lot on when I'm working with, when I'm collaborating and working with data visualization. So the first is data communication. I think art and other kind of creative outputs have this opportunity to think of new ways and new formats to communicate research that's happening in many disciplines. I've worked with ecologists and marine biologists. Of course, my wonderful collaborators here tonight. I've also worked with physicists and haptic researchers. And in each of these groups, there's some wonderful stories to tell. And my work using emerging technology and interactive technology creates new opportunities to engage with those stories in ways that are hopefully very interesting and engaging for a public audience. Which leads to the second thing I often engage in, which is immersive experiences. So we're all, especially in the last year, very used to being, seeing things on a screen in maybe a fixed format. But it also, that gives us an opportunity to have experiences that can be more immersive or more interactive. So you'll see in a little bit an example of projecting data into a three-dimensional space and being able to move around in that space. We'll get to that in a minute. But then aside from communication of these stories that the data tells, there's also this other motivation that I have when visualizing and working with data, and that is this idea of connecting form and information. And so one of the really important aspects of artists using technology is all these really powerful tools that come with that technology, concepts from engineering and computer science that allow for things like generativity and emergent behavior and machine intelligence and all these really interesting ideas that are on the forefront of a lot of research. And how can those ideas actually generate form and art? How can ideas of complex algorithms create physical or digital structures that we can represent in an artistic setting? And so that's one of the things that motivates my reaching out and engaging with these scientists, is to see, what does wildebeest movement look like when it's put into an immersive artistic experience, as well as brown pelicans. And so you saw a little bit of that in the beginning of the lecture today. But before we dive into that, if we go to the next slide, I can show you an example of what the more data communication side of things looks like. So this is a project with a researcher out here at the time at UC Santa Barbara, Kelsey Bisson, and her work investigates carbon flux in the ocean, and she tries to build mathematical models that represent carbon in the ocean. And we wanted to work together in part because we had this goal of communicating the complexity of Earth's oceans and to go beyond the mindset of like the flat blue ocean. I think a lot of us can, I'm certainly guilty, and I live here in Santa Barbara, I'm certainly guilty of looking out and seeing this beautiful blue plane basically, and not thinking about all the complexity and diversity that exists inside of it. And so with this piece, what we sought to do was create an interactive and immersive visualization that used this visual metaphor of particle systems, which you'll see a lot of in my work. And so basically what's happening in this piece is the density of these little particle clouds represents the amount of carbon flux that's happening at that location in the ocean. And so you can see in this version, this kind of fixed version of the video, we're getting these different camera angles and things. But on the interactive version, a user could navigate this 3D space and check out certain areas of interest. I think a lot of the work I do is very similar to world building or even game design. If you think about creating and curating these three-dimensional spaces that can be navigatable. And so this was an example of trying to have that immersive setting and communicate the story about what's really happening in some extent in Earth's oceans. And we were able to project this in this giant three-story dome here at UC Santa Barbara, and people could kind of stand in the middle of the Earth and observe what was happening around them. Now, for the work that I worked on with Autumn, Lynn, and Jared, this was actually kind of on the other end of the spectrum in some ways from more communication-driven motivations, let's say. So if we go to the next slide, we can take a look at the work Paths of Change that draws on Jared's wildebeest data and Autumn, Lynn's pelican data. And so this was a more of an example of where I was really curious about the formal structures that could be created from this movement data. And in particular, the main visual metaphor that I worked with on this piece that I found really exciting was this juxtaposition between, in some ways, a relatively simple idea of where an animal is at any given point, a latitude and longitude coordinate, and that's some one dimension of the data at least, but also how, as I've learned from discussions with Jared and Autumn Lynn, how that's just like the very beginning of the story, and that really just is a little window into all this complexity and diversity that they're asking all these really interesting questions about in their research. And so I wanted to visually represent that juxtaposition between sort of cut and dry locations on a plane, as well as all this complexity. And that's what you see in these particle systems, where the behavior of the movement of these animals cast these kind of particle showers that interact and disperse and have their own dynamics, representing this really rich space of complexity that they're investigating. So in this work that you're seeing now, it's showing 3 different wildebeest as they move around, and then those particle systems that are part of it. And the other half of this piece, where I work with actually Aunt Hazel, who you met before, this was a different take on it, where I wanted to give a sense of the formal qualities of this movement, and again represent that seemingly simple idea of a location in space, but with all of the complexity that comes with the environment that this pelican's engaging with. Complexity in terms of its impact on the landscape, other species, us as humans, and it's just such a rich space that I love that idea of having those 2 things coexisting together. There's a link in the chat that has the full version of this video, and it has some sound with it as well that kind of sets the tone for it. So I encourage you to check that out. Then the last thing I'll say, if we go to this last slide here is a lot of this work that I'm describing, interacting and collaborating with scientists and researchers in different domains. You can find at any three of these links here, and including the interactive version of that Flux project and the full video of this animation that you saw tonight. And I'm just very thankful to Jared and Lynn for letting me be a part of their world and their research, because it's fascinating, and I just love engaging with their ideas.
Thank you, Mark. Well, let's have a little more fun here and have a conversation, based on what you've shared about your work and these presentations. I think all of them in some way suggest a evolving kind of research practice, where you're continually thinking about methods and tools about how you might approach what you do. And one aspect of that clearly is, from the Smithsonian side, the use of these new technological tools, whether it's GPS trackers or more complex trackers that include GPS and communications technologies. And of course, the introduction, as Mark kind of is pointing to, of big data and machine learning and AI as like fundamental tools as we deal with these massive amounts of data that we are able to collect and to represent them in different ways, right? So I thought it might be kind of useful for the audience for you to talk a little bit about, how and why you came to, be enamored by the power of these tools to apply to your own research, and what you thought they might do to be able to advance what you're doing. Maybe Jared, you can start.
Yeah, sure. Yeah, I don't know. With my research, I've always had an interest in kind of merging the biology with the technology. And I certainly think with these new technological tools, we are able to measure things like we never could before. Audubon mentioned the terns, the longest migrant that's ever been measured. These are things that we couldn't measure any other way. And so I don't know, it's pretty phenomenal the amount of information that we're able to collect at this time. The challenge is, sometimes what do you do with all that information? Beyond what we talked about here with just the geographic position of how we're tracking these animals, some of these animals actually have accelerometers that are fitted on them as well. And that's even another dimension. And when I say accelerometer, sometimes there's information that's collected on this animal, let's say 6 positions or 10 positions per second. And so it means, at least from a scientific perspective, you're merging all these different skills of the biology of the animal, some technology, maybe even some computer science or programming to actually get a result from everything that you're compiling together.
I'll chime in to continue the science story there. I think there can be a feeling among some biologists that technology serves to disconnect us from our study system and nature, and that some scientists become armchair biologists or keyboard biologists. But for me, studying marine systems, technology has served the same purpose as binoculars. So I can't dive 3 miles deep with an elephant seal to see what it's doing and watch where it's going. And I can't follow it myself. I can't follow an albatross by flying myself behind it. So the technology has really allowed us to have binoculars trained on these animals throughout their full migrations. And that's just amazing to me.
Yeah, and from the art standpoint, some of these emerging technologies and tools that we have, for me at least, allow me to approach creating a work like you saw tonight in a way that might seem very different from other artistic approaches. And namely, I like to approach this work in a context of what I like to think of as like system building. So, in both of the pieces you saw tonight, as opposed to maybe a more manual practice like painting or drawing, where it's kind of sequential and linear and you build it up over time. It's almost the reverse approach, where I will build an environment, I'll create a world, and I get to define all the aspects of the forces and the dynamics and the behaviors of everything in there. And once that space is created, I can then take this movement that Jared and Autumn Lynn have shared with me and drop it into that world and see the way it unfolds and plays out in the structures. And so it's almost a reversal of how you might think about creating an art piece. But it's one of the things that's most exciting to me, is thinking about art as like a systems building approach, which is certainly a nerdy way to go about it, but I really enjoy it.
And just to add on to that, perhaps, Mark, I mean, I presume that approach is highly dependent on tools like AI or machine learning.
Yeah, so that's one of the interesting things too, is a lot of these tools, whether it's developments in machine learning and things like that, typically are built for very I don't want to say that art is not pragmatic, but more pragmatic purposes, and have these kind of goals of efficiency and optimization and dealing with large data sets. I think the unique angle that the arts bring to it is that we can use those same tools to be more speculative and more imaginative about the worlds that we build. And we can try to make things not efficient and see what happens. And we can try to build structures that that deviate from how you might normally use some of those tools, which in some ways provides a critique onto the development of those tools as well, which is another interesting angle that the arts kind of bring to developing technology. But it's also a very strong driving factor of my ability to build these systems that I can then interact with Jared and Autumn Lynn's work with. It definitely is like the infrastructure for that.
Yeah. All of what you have kind of presented in different ways allude to this kind of complicated word called abstraction, right? In the scientific sense, it's about purposely reducing the complexity of the world to study some specific phenomenon. And I guess there's a kind of a comparable way one would think about what you're doing in your work, Mark, to that kind of framing. Does that concept, or it's kind of either in the foreground or the background, have kind of importance for you in your research enterprise and how you think about what you do, and how it may serve a role in your kind of research program in some way?
Yeah, for me specifically first.
Sure.
Sure, yeah. Yeah, I mean, the role of abstraction is really interesting when working with folks like Jared and Autumn Lynn, because there's a lot of decisions that get made about how to present these stories and what we want to communicate and what we want to highlight, what we want to minimize. So there's certainly versions of this piece that could exist that might be more like the animation that Autumn Lynn showed, where you have this really great sense of context of the landscape and their position in time and space. But when we want to focus on things like what are the formal qualities of these movements and more abstract complexities, sometimes it can be nice as an artist to filter out some of those ideas and leave the audience with just thinking about the movement itself and what the qualities of that are. So that's something I really enjoy working with. And I know that Jared and Autumn Lynn also make a lot of those kinds of decisions when they're working with, building their communication as well.
Did you want to add anything to that, Jared?
Yeah, I would just say, we call like that occurrence distribution that I described, I call that kind of an abstraction, because when we collect information about these animals with these technologies, we don't actually get a full trajectory. We get kind of a snapshot, right? Usually a lot of these devices, they collect at some kind of temporal interval. And in that particular animal, we collected every hour. And so in between those points, those discrete points, we're kind of waxing poetic and trying to connect those points in some ways. We're using obviously mathematical models to do so, but in some ways, I feel like there's a really strong connection with those mathematical models and also, an artistic rendering of where those animals are going.
And I'll add to that we always infer behavior from the data that we've collected. That's one of our primary objectives. What is the bird doing there? And can we tell this from the movement path? Are they diving after a perch in the Chesapeake? Can we see that in the data? So we tend to have to infer from these abstract movement paths what the animals are doing. And one of the things I really loved about the abstraction that Mark created for the Brown Pelican is that it takes it to a whole nother level, in that I almost never remove the environment from even my most abstract abstractions. And by Mark kind of putting the pelican in the box, and really what you're seeing is the movement path, but it looks like a bird. It looks like, wings fluttering and feathers, but it was reminiscent to me of the Holland Island house, and kind of, framing my whole, the place I'm from and the culture kind of into this Holland Island house, and this pelican kind of moving in. But that Holland Island house doesn't exist anymore. So that's even another layer of abstraction. So I just really loved how his work made me even more connected to the cultural story I was really trying to tell with some of these data.
Yeah, well, that's fascinating. I mean, I think, for both you and Jared, right, who do field work, and I think it was, beautiful of you, Autumn, Lynn, to share with us, your own sort of personal experience, growing up in the Chesapeake. One through those experiences of field work or just life experience generally, you are kind of filling in, if you will, the kind of complexities that aren't represented in the abstractions, which perhaps gets at the question as you kind of balance these things. I mean, what has motivated you as researchers, as scientists, as artists, to take up these particular initiatives and see them in relationship to their own lives, and not just perhaps as scientists alone. Maybe you can start, Audubon.
I think the ability to tell stories with science and to connect it on a personal level is really one of the only ways that conservation will be achieved. Jared said in the beginning that what we love, we will conserve and understand. And I think that is a large motivation of, as scientists, we have our ways of storytelling. We have scholarly journals and we have scientific conferences, but it's really important to us and many scientists at the Smithsonian. That's one of the reasons we love working at the Smithsonian, is that sharing stories with the public is also a primary objective. So it's kind of these dual things where there's this scholarly curiosity and we want to understand Earth and its systems and its animals, but then we don't want that understanding to just sit on our computers or in journals. We want to share that with the world to also just inspire other people to feel about nature the way that we do.
Right. Jared, I thought you had a kind of a great sort of characterization of this. It'd be nice to share with the audience on that understanding aspect, and to understand something is to enable either to see its importance or to have this deep feeling toward it.
Yeah, I mean, I think all of us, we get really attached to the animals that we study. And oftentimes it is frowned upon for a scientist to actually name the animals you're tagging. Autumn mentioned on Hazel, and it provides this connection. With the wildebeest that I mentioned, all of our wildebeest actually were named by local Kenyans, young students. In a way, these are all animals from their backyards, and even talking with these kids, we all have our preconceived notions on where these animals go throughout their lifetimes. The devices actually, sometimes they're right on and they confirm what people think, but then other times the devices actually tell us something very different, and these animals move to areas that no one ever imagined. And those are certainly things that we're finding. But I think the important thing is this connection that people have to their landscapes, which is really true in Kenya. And also with the species that they share the landscape with, land or seascape.
Yeah.
So from the world of AI, the artists look at this.
Yeah, well, actually, it's kind of along the same lines of this idea of connecting it to what we know, and also like naming things in a slightly different context, because I love engaging with creating and observing beautiful structures and forms, and like that's kind of my bread and butter as an artist. And I could do that sort of in a vacuum. I could visualize complex algorithms in and of themselves, and it would look very interesting. It does. But there's something way different about interacting with something something of importance from the real world, from research that's ongoing, knowing that these structures are actually tied to something that has a rich story to it, and that has big impacts for our world, our communities. And so to me, being able to engage and to build and create art through those avenues is just so much more meaningful. And I think, and I hope that it opens up the opportunity to have conversations that are more inclusive too. So for folks that might not be in an academic community, to be able to read about some of these ideas that Jared and Autumn Lynn engage with, perhaps seeing it as an art piece online or in an exhibition might be an entry point into that topic, and just foster some questions and conversations. I mean, like we're doing tonight, actually. So that's kind of what motivates the way I approach this.
Thank you, Mark. So we're at the 6:30 point. So I think we probably want to segue into questions from the audience. You want to enable that, Kate, for us?
Yeah, thank you. That was just so great to get to be behind the scenes. And obviously, I've been working with this group over the past couple months and getting kind of snippets of their work and what they would talk about tonight. But there were a lot of things that I just was even more curious about, and seeing their materials that they had put together. And I'm really enraptured with this conversation. So thank you all. We do have a couple of questions, and I have my own questions, but I'm going to be nice and save those and let the audience ask theirs first. I have one kind of like a investigatory journalistic question right off the bat for Autumn Lynn. We had an eagle-eyed viewer notice a sponsorship from ConocoPhillips and the Migratory Bird Project, and they would love to speak for you to speak to that and what that motivation was in them getting involved.
Sure. Well, I can't really speak to their exact motivation. Them funding the project was a little bit before my time, but many companies have a philanthropic arm, and ConocoPhillips has a charitable givings group that focuses on biodiversity. And so they have a grants program, and one reason I think they might have supported our work, and they primarily fund a lot of our field work and on our tag purchases. And it's really interesting. ConocoPhillips has areas of operation throughout North America, spanning from Alaska, Alberta, Colorado, and Texas. And if anyone knows anything about birds, that mirrors the central flyway for birds. So birds divide into different migration paths across the planet, and the central flyway congregates a number of different bird species. So they were really interested in how birds use the habitats and their areas of operations and might connect their areas. And also, in many ways, learning more about the birds that nest in their habitats to try to maybe get in front of any impacts. So in Alaska, for example, that's a place where many species nest right next to their paths and through the tundra. So I think there are lots of reasons why companies might get involved in supporting biological work for their own reasons, but then also for their charitable giving.
Thank you. That makes a lot of sense. And it does kind of like flesh out to like a lot of what we've been talking about is taking the connection between the research that you all do and how it kind of bridges into other parts of those of us who aren't involved on that side of that, how it bridges into our life. Thank you. Also have a question that's specifically for Jared, which is if you could describe some of the barriers to migration that you've learned about over the years and what those look like and what forms those take.
what's the barriers, meaning the barriers of movement that we're seeing?
Yeah, barriers to migration paths.
Okay, yeah. Certainly in Africa, and I guess globally, what we're concerned about is infrastructure development, really. In Kenya, there's just so much expansion on roads, railways, pipelines. The difficult part that we see is that, these development projects are happening so rapidly that we actually can't keep up with them to provide recommendations fast enough. The other thing that we see, especially, well, this is actually global now, is the rapid expansion of fences. I mean, I showed that one image of pronghorn that fortunately we found with pronghorn that they actually will go underneath fences. And so a lot of the fences in the American West, there is recommendations to facilitate connectivity simply by raising that lower strand of wire. Wildebeest are not so endowed. They try to go through the fence. And so it is a major problem, and it's something that we're currently engaged in trying to remediate. And that really means working with the local government officials and showing historic movement paths. So to try to prioritize where animals historically have moved across the landscape.
Thank you. Right. Yes. There's so many things to say about it, but I have a lot of questions. So I'll just keep on, but thank you for that. It makes me think of driving out west, of course, like in the US, where there's just those fences everywhere and you see the deer kind of trying to creep around them however they can. Let's see. I'm sorry, I'm just choosing the ones that will have the best kind of flow and segue. One question is, I guess for everyone, but does the visualization of your work illuminate different kinds of things for scientists versus non-scientists? And so that could be, kind of answered in collaboration with all three of you.
Yeah, I guess I'd be interested in hearing what Mark had to say first.
And the audience too.
Yeah, true. Yeah, definitely. I mean, one thing that's really interesting about sharing some of these visualizations, either with scientists, either the ones that, like Audubon and Jared, who I'm working with, or other folks who know the field, is they're very in tune with all of the things that I either choose to hide or highlight or abstract. And so they're very aware of when I've made a decision of what I'm going to highlight. And so those conversations become very interesting, because then it's like, oh, like, that's interesting. Like, why did you, go very minimal and obscure this fact? Like, what was your motivation there? And but also it's really great feedback for me, because sometimes I'm so excited about maybe the way something looks that I've perhaps overlooked something that's a really important part of the story that I want to make sure it's included. So that ends up becoming a nice back and forth to think about that. And then maybe on the flip side is sometimes when I present this work, more generally in the public, and especially if maybe someone comes across it without something like this, where they get more context or they don't get to see like a plaque or something like that. Sometimes the surprise of like what's actually generating this movement is a really fun feature of the work itself. They're like, oh, this is like this nice, interesting, complex particle system. And like, yeah, and it's from wildebeest. And they're like, what? So there's a fun part of that too, that there's a bit of a surprise that I enjoy in that work. So it does have some kind of different, it lands differently in different groups for sure.
And Autumn, Lynn, and Jared, you could speak to that question as well, but I think there's a follow-up question that's more relevant for the two of you. Now I see what the thought process was. But yeah, if anybody that's watching in the chat has anything to say about that too, that would be fun to chat about. So the follow-up question then is, has seeing the visualization in this way changed anything of what you look for in your data? Has that kind of working with Mark or focusing on visualization changed the way that you collect your data?
Well, I'll start because I have two, I think. And what y'all may not know is that this is kind of the world premiere of these visualizations, I think. It's safe to say, at least for Hazel's. And so I've only seen them for the first time, recently as well. But I think two things. We do often employ animations in our work, and they look more like what we call spaghetti plots, where it just looks like a bunch of lines that you throw on a map and they kind of fall down the wall, spaghetti plots. And what I like about what Mark showed is he actually encouraged me to take more time sitting with the data because his animation is slower and in some ways more fluid. We try to show a whole full year migration in 1 minute, so that we can show audiences. But I like that Mark made me pause with the data a little bit more, sit with it and watch it for a longer period of time. And one thing we didn't mention is that his animation includes depth. So when pelicans feed, they feed by diving, and they're plunge divers. And so that includes not only their aerial movements, but when they dive to get prey into the Chesapeake. And I haven't really explored those data too much yet. So it was really nice to kind of see how this all came together.
Yeah, and I guess for my part, one of the things I really like about, there's many things I like about Mark's animations. One of them is the multi-dimensionality, because we're talking really about, and at least in the beginning, about an X and Y position and then time. But then there obviously is all these other dimensions that we're trying to relate the position to. And I think some of that starts to be captured in what Mark is doing. The other thing that I really like is I think sometimes we get really focused in on single individuals, and oftentimes we are focused on a really small sample. And so one of the things I like with the wildebeest animation is Mark was able to put 3 animals together, because none of these animals are moving in isolation, right? They're making really complex decisions because of the environment, because of conspecifics that they're moving with. And that's the part that I find really, really interesting. And it's a thing that's hard to incorporate in scientific study because it's so very complex.
That's interesting. I think from a non-scientist perspective, we would not assume that you're usually working with really small sample. I think we would look at your spaghetti plot, right, and think that it's kind of, we assume that you're tracking a herd or, some large group of animals. So that's really interesting.
I think it's useful to step back just a little bit for the context, right? And kind of comes out from these different responses. I mean, this fundamentally, this is what I've loved about being engaging with my colleagues here. This really is kind of a golden age of conservation science, right? I mean, the advent of all of these new tools, whether through the capability to do tracking or the kind of tools that Mark used, these are all just sort of coming into fruition, and their power and their value as research instruments are just really beginning to be appreciated and applied by lots of different groups. And I think part of the fun thing here that's kind of happening behind the scenes is all of their interactions, not only with people like Mark, but kind of other collaborators, people who have other expertise in imaging and visualization and all that kind of stuff. So I mean, the way this research is coming together is just so profoundly different, I think, than probably 10 or 15 years ago.
Yeah, I appreciate you pointing that out. I was kind of mind blown when Autumn, Lynn, you pointed out that the first tracking of birds was 1984, because I don't know, to me, I just feel like it's, like you said, Martin, it just seems like it's important to zoom out because it seems like it's something that's just been around with, our nature shows and all those wonderful things.
Right.
I have a couple of more questions, and then maybe we'll get to one that we had kind of talked about as a group when we met. So it's kind of like, having this be the golden age of conservation is not a moment too soon, right? Because of what we're facing with climate change. So there is a question about how those land and air migration patterns change due to changing landscape and climate, and how can observing those changes inform the bigger picture in terms of climate change?
That's a great
question.
Just
a small question.
Yeah, small question. But I can start to continue the story of Hazel and the Chesapeake Bay, because I think there's two aspects to that pelican story you know, we often think of the doom and gloom of climate change and that everything's changing, but this pelican story in the Chesapeake starts off with this release after DDT was banned. Pelicans crashed on the East Coast, and DDT caused eggshell thinning that made it so chicks couldn't hatch, and brown pelicans were endangered at a period of time. And then when DDT was banned, that was a single point, you know, that was really causing population declines, and brown pelicans released. And we think what happened is that as these populations were rapidly reproducing, in the meantime, habitats had been developed in South and North Carolina and Florida, and they just started growing, the population started growing and expanding north. So that's really a success story. From the first nest of brown pelicans in the Chesapeake, we have 3,000 to 5,000, and I tracked 6 birds. So that goes back to that abstraction concept. And but we expect them to continue to move north with climate change and land conversion and sea level rise. So it will be interesting to see what happens. There are pelicans every year in New Jersey, and you know, they go up that far, but they're not nesting there yet. So stay tuned for probably some different migration patterns and nesting patterns of brown pelicans with changing climates, and then impacts along the coast.
Yeah, and I guess certainly with terrestrial mammals, the difficulty is these animals share the same landscape that we do. And you know, one of the things we've set up globally is a system of protected areas, which is, it's a great thing. But it's problematic for terrestrial mammals that are, let's say, tracking environmental conditions, right? And if those animals stay inside the protected area, then everything is fine. But what happens in a dry year when those animals actually have to leave the protected area and, you know, basically find those resources? That's where the real problem exists, especially now, because outside these protected areas, you usually have heavy settlement, sometimes agricultural land. So land that's not very suitable, it's not very natural. And one of the things that we are doing with partners is to try to create buffer areas around protected areas, so that, you know, in changes in climate, that it does facilitate some flexibility, what we would call plasticity and movement in year after year, so that these populations do persist.
Thank you. Yeah, I don't know if Martin or Mark, you had anything to add. Might not be your area.
I'll let the experts put the final word on that one.
Yeah, that's kind of a big question. Again, I think like for a lot of us non-scientists, like, you know, we do kind of like whittle it down to that, like, well, what are the implications? Like, what are the strands of connectivity to talk about climate change when you do this this work? And I was just thinking too that, you know, this work is so crucial because that pesticide was banned, but of course those things can come around again. And so it's crucial to have that data to say, well, it was banned and look what happened. So we need to make sure that we're vigilant on those legislations and policies. Great. Okay, well, we are coming to the end, but I did want to kind of ask a broad question that can get everyone involved about, you know, we talked a lot about how the goal of the Smithsonian is to disseminate information, and that's kind of the goal of museums in general. Obviously, you know, as a museum educator, I take that very seriously. So if all of you could kind of, to end, speak a little bit to what are some of the ways that the partnership of Movement of Life, artists, other researchers, and museums can work across the Smithsonian Institution and affiliates to educate the public about our world, and what role does visualization play in that education?
Mark, I feel like you have the highest level view of the Smithsonian. That one's for you.
Well, I think, you know, it's that particular point, Kate, I mean, I think has been over especially the last few years a tremendous motivator at the Smithsonian Institution. You know, that was why I tried to sketch out, you know, this entity within the Smithsonian called the Conservation Commons, Yes, it's there to facilitate communication among researchers and look at the synergies between the work of different communities of folks within the Smithsonian and their collaborators outside the Smithsonian. But as a public-facing institution, we're always kind of looking for ways to bring the challenges, and climate change is the challenge of our time, to our audiences and help them understand it. And I think, one marker of that, of course, is this, kind of conversation we're having, including Mark as an artist, as a means to kind of communicate with audiences. Within the Smithsonian itself, the art museums, our National Air and Space Museum, American History, the National Museum of American Indian, are all sort of taking up, environmental or climate topics. So there's a kind of a broad palette of interest in, kind of bringing these issues to the public and showing them what the questions are, and kind of getting them potentially, as Mark said, to go off and follow up and do a little thinking and research on their own.
And at least one of our satellite tags will be in the National Air and Space Museum as well, to connect our work at SCBI and the zoo, the Smithsonian Conservation Biology Institute, with satellites and the story they tell and the stories that National Air and Space Museum tells.
Yeah, I guess I also just think it's just really interesting that all Mark's animations are grounded in data. It's actual things that we collected. And I think just, art, I think, speaks to people in different ways. And I think that's what we really need to do. We need to find the things that are really interested in different people and get them more interested in these species, because they're unfortunately we're losing species rapidly. And if we can get more people interested in the songbirds that visit their feeders, that are only there for a few months, and then they migrate to Panama and then they come back year after year. I mean, it really is fascinating to look at where these animals go. And I think any way that we can draw people in, I think is ideal.
Yeah, and I'll just follow up on that too, which is, I think one of my motivations to pursue this kind of collaboration and this kind of art is, I was very fortunate to, my partner actually does research in Kenya, and I was able to go out there one year and help a little bit, but mainly to see these amazing animals and the way they move, and to see these trajectories kind of up close and personal, and not a lot of people get that opportunity. So in some ways it felt like, if I can use sort of my role as an artist to make one more bridge into that world, it seems definitely worth doing. And and so these kind of collaborations, I think, are like one way to connect all those dots for folks that aren't fortunate enough to be able to see those things firsthand, and to, like Jared was saying, we care about what we understand and we love what we understand. Like that's I think it's one way we can approach that.
Thank you. Well, I think I know the answer to this very final question, because you said that this is kind of a world premiere of a lot of what you all have been working on together recently. But there was a question about if any of this has been published yet, and if so, in what kind of publications, this collaboration?
Not yet. And actually, we haven't even talked about that, I would say. So
yeah. Good to know. Well, surely something that's interesting, and we'll be interested to kind of keep tabs as an affiliate, and having gotten connected with you all on where it goes. So thank you all so much for doing this. This was really a really great kind of culminating event for us for our lecture series. It was very different from anything else that we did this year, and it was just wonderful to hear these different perspectives and bring in this much more science and tech side of the conversation about our environments and how we can think about them and respond to them and take care of them.